Okay, so in flexural reinforcement class, hahatiin natin to. We have the longitudinal reinforcement and the reinforcement on the short side. So in longitudinal reinforcement class, parehas mu, equate na lang natin siya ng ating VMN. So again, I'm going to draw the footing. So para mas madali din to, kagaya nung ating ginawa sa two-way shear, gagawin na lang natin siyang Q average. At ang critical part ng moment at ang critical na part ay nasa face of the column. So, sa face of the column, asan ang face of the column class? Andito. So, andito ang ating critical. So, saan tayo mag-moment? Mag-moment tayo dyan. Okay, so paano natin makukuha yung moment na yan? Mu is equal to, ano yung Q average natin? 222 kPa. At ano tong width na to? This is 2 minus 0.4 divide it by 2. This will be 0.8 meters. Okay? So, mu is equal to 222 times 0.8 by 1 times yung distance ng centroid, 0.8 over 2. So, mu is 71.04 kilonewton meter. Okay, equate na natin to sa ating VMN para mapalabas natin ang ating rho. 71.04 10 raised to 6 VMN 0.9 F prime C B 1000 W IBW D 400 square omega 1 minus 0.59 omega, and omega is equal to 0.024177411. Rho is equal to omega F prime C over Fy. Substitute rho is equal to 0.001206. Compare it to rho mean, that will be 1.4 over 414.7. It is 0.00337. So, mas malaki ang rho mean. So, use rho mean. So, ang magiging AS natin is equal to 0.00337 by B, that is 1,000, by D, that is 400. It will be 1350.37 mm squared. If we use dB na 20 mm, N is equal to 1350.37 pi over 420 squared. It will be 4 point something. Going to use my calculator. 1350.37 pi over 4 times 20 squared. 4.29. Say 5. So use 5 20 mm diameter RSB for longitudinal reinforcement. Okay? Next, short reinforcement naman tayo. So, sa short reinforcement naman, so, kung kanina sa longitudinal, okay, hindi ko pala na drawing class, pero sa longitudinal, kung ito yung ating long side, ito yung kinukuha natin kanina na part, diba? Para ang reinforcement natin dyan ay, ano ang reinforcement natin? Ito ang reinforcement natin sa longitudinal. Ganyan siya. Yan yung reinforcement natin. Ngayon, sa short naman, ganito naman siya. Ang short reinforcement natin ay so ganyan ang short reinforcement. Ang critical area naman natin ay itong section na to. So, ito yung matatanggal na area. So, para hindi yan matanggal, mag-provide tayo ng bakal dito sa part na to. Diba? Ganyan. Providean natin yan ng bakal para hindi siya makrack. Okay. In one-way footing and two-way square footings, reinforcement shall be distributed uniformly across entire width of footing. So that is in one-way footing and two-way square. However, in two-way rectangular footings, reinforcement shall be distributed as follows. Reinforcement in long direction shall be distributed uniformly across the entire width of the footing. Yun yung ginawa natin dito, class. So, yung 520 mm across the entire width of the footing yan. So, in short reinforcement, for reinforcement in short direction, a portion of the total reinforcement, gamma SAS, given by the equation below, shall be distributed uniformly over a bandwidth. So, over a bandwidth that is centered on the center line of column or pedestal equal to the length of the short direction. So, and 1 minus gamma SAS shall be distributed uniformly outside center bandwidth of the footing. So, dito, if this is a rectangular footing, class, at ang ating dimension dito ay 1 meter, kukuha tayo ng 1 meter dito sa gitna. At ito yung tinatawag na center bandwidth. So, ang center bandwidth natin ay ito. Itong part na to. So, lahat ng bakal dito, tatawagin nating AS1. Tapos, yung matitira, parehas equal AS2 tsaka AS2. Ibig sabihin, hindi parehas ng distribution ng bakal. Okay? Bakit hindi sila parehas? Ibig sabihin kasi niyan, mas madaming bakal ang ilalagay dito sa gitna. Ibig sabihin, pag mas madaming bakal ilalagay sa gitna, mas siksik yung kanyang bakal, mas maliliit ang spacing compared dun sa nasa gilid. So, yun yung gagawin natin sa ating short reinforcement. Okay? So, kung 1 meter din dyan, ang matitira na lang dito ay ano? Tig 0.5. And 0.5. Okay, so, before natin makukuha yung AS na yan, first kunin muna natin yung ating MU. So, MU equate natin sa ating VMN. So, ang MU natin ay, saan ang critical ulit? Dito sa face of the column, diba? So, mag-moment tayo dyan. Ano yung ating Q? Ang Q natin ay 222 times, this is 1 meter minus 0.4, that is 0.6, divide it by 2, that is 0.3. Tama? This is 0.3 by area na 2 by 0.3 over 2. It will be equal to what? 222 times 0.3 times 0.3 over 2. This is what? 19.98 kilonewton meter. Okay? So, equate natin 19.98, 10 raised to 6, V 0.9, F prime C 20.7. Ang B natin dito ay ang B na natin dito ay ito. This is 2,000. It's not 1,000 anymore. So, 2,000 times 400 square omega 1 minus 0.59 of omega. So, ano ang omega? In our calculator, 19.98, 10 raised to 6 equal to 0.9 times 20.7 times 2,000 times 400 squared times x 59x. Shift, solve, at ang x ay 3.358 times 10 raised to negative 3 at ang omega niya ay times 20.7, well, it will for 14.7, 1.67 times 10 raised to negative 4. Ano yung rho mean natin? 1.4 over 4, 14.7. That is 3.37 times 10 raised to 3. So, ano siya? Rho mean governs. Diba? So, ang AS natin ay, so use what? Use rho mean. AS natin ay 3.37 times 10 raised to negative 3. Ano yung area? 2,000 by 400. So, ano ang AS? Times 2,000 times 400. This is 2,700.75 mm squared. So, i-divide na lang ba natin ng area ng isang bakal then distribute? No. Kunin muna natin yung nasa center bandwidth natin, that is AS1. So, yung sabi sa NSCP class, ang formula daw ay reinforcement in bandwidth, that is AS1 over total reinforcement AS is equal to 2 beta plus 1, where beta is the ratio of the longer side of the footing over the shorter side of the footing. So, AS1 at ang AS natin ay 2,700.75. 2 ratio of shorter to longer to shorter, that is 2 over 1, that is 2 over 1 plus 1. Okay, so AS1 is equal to 2/3. So imagine 2/3 nasa gitna tapos 1/3 pagkahatian nung nasa outer na both sides, so tig 1/6 lang sila. So AS1 is equal to 1,800.5 mm squared. So, ano to? AS. So, ang number of bakal niya, if we use dB 20 mm, AS1 is equal to 18.5 over pi over 420 squared. Divide it by pi over 4 20 squared, ano siya? 5.73 say 6, diba? Tapos, yung AS2 naman, so since mula dun sa figure natin kanina, 2AS2 plus 1AS1, yung AS1 yung nasa bandwidth, center bandwidth, equals AS. So, AS2 is equal to what? Yung naiwan na lang. Ano yung naiwan? $2,700.75 minus 1,800.5. Divide it by 2. 450.125. So, use dB 20 mm. N naman niya is, mali pala ito, but AS pa rin to. It should be N. N is equal to 450.125 pi over 4, 20 squared. Ano siya? 1.43. Say 2. Okay, so paano na natin i-drawing yung ating footing? So, yung footing natin ay okay, so i-drawing na natin siya. Ito ba yung gitna? Mali, bias. Saan ang pinakagitna? 1, 2, so, yan yun class. So, sa short reinforcement, drawing natin yung short reinforcement natin. Dito ata. So, 0.5 meters. One meter. 0.5 meter. Tapos, so, dito siya. So, ang cut niya ay dito. Hindi ko alam kung tama yung drawing ko, pero ganyan. Yan ang cut niya. At yung bakal natin dito ay 2. Pwede naman siguro natin gawing 3. Okay, tapos dito ay 6. So, 1, 2, 3. Okay. So, dito ay ano. Tapos, yung longitudinal natin ay 5. Ibang kulay na lang yung longitudinal. Longitudinal natin ay 5. 1. Okay, so ganyan siya. So, lagyan natin ng label. Ito ay 520 mm RSB. Tapos, dito ay 20 mm RSB. Tapos, dito naman ay 620 mm RSB. Tingnan ko namang maayos naman tong isa. Okay, so ganun din dito. Ayusin nyo na lang drawing nyo. Huwag nyo gayahin yung drawing ko kasi hindi ako proud. Okay, so 220 mm RSB sa labas. Tapos 620 mm RSB naman sa gitna. So bakit ganyan, class? Bakit merong separate na anong rason, anong provision? Bakit meron itong provision na to, 'di ba? Bakit pa to kailangan? So dahil kailangan kasi, class, mas madami kasing bakal dapat sa gitna. Mas compact kasi dapat yung bakal doon. Para mas compact doon, mas maliit yung spacing nila. Dapat mas madami doon compare doon sa outer side. So, ganun ang reinforcement ng rectangular footing. Hindi siya kagaya ng square footing na isang side lang yung i-compute mo na equally distributed and then kokopyain mo on the other side. Dito, dalawang side yung i-compute natin. So, para sa longitudinal reinforcement and para sa shorter reinforcement. And always remember, class, on shorter reinforcement, you will have to get the center bandwidth. So, iba yung distribution ng bakal. Hindi siya equally distributed. Okay, so if you have questions, class, you can ask on our group chat. Pag may mali dito sa computation na ginawa ko, you can correct me.